Got a Nakamichi CA-7A control amplifier here to repair from a neighbor. Okay, I got the power supply board out. Looking at the bottom here, there's been some hands in this thing. It's quite a mess right in this area. I'll flip it around here. Yeah, somebody's tried to do some things here. Ruined a lot of the traces. So there's been a lot of things done under here. You can tell by all the rosin that's left behind. It wasn't cleaned afterwards. So, got my work cut out for me. I did find a schematic, but it's barely readable. So it's going to be fun figuring these values out. I know the 6s and 8s are probably going to be an issue. Yeah, pretty nasty. But it's the best one I could find online for this thing. Time to start going through it and seeing what's bad. Took isopropyl alcohol and cleaned this board up as much as possible in this burnt area here. There were 2 resistors there that are burnt that I pulled out. Transistors seem to test okay. Schematic here, I had to write in the resistor values because you just can't see anything the way this thing was scanned. So R4, 17, and 18 are 26 ohms, 26.1 ohms. So they were burnt, need to be replaced. These transistors seem to be okay. But I got to find what caused this to blow. And something out here on this is the plus 35 volts coming out. And by looking at whoever was in this thing had cut one of these red wires here. And maybe there's a short out here somewhere that caused this to go. So I got to check that before connecting all this back up. Okay, this is all resoldered and cleaned up best as possible because things got pretty hot in this area. And I replaced the 2 resistors. So these are 5%, but I had a bunch of them. I selected them to get the 26.1 ohms. These are selected. I got 26.2 for both of these resistors. So those are replaced. Now I'm going to put this aside and take a look at that main unit. Find out if or where there's a short that caused all this to go bad. This red wire was cut and taped. This is the plus from the power supply, plus 35 I think it was. And this was cut. So maybe someone was trying to find a short circuit wherever this wire goes. And of course it goes all the way to the bottom board somewhere. So we'll take a look, do some checks on that. Using the old Simpson 260 here. We've got, of course I'd have to re-zero it because it's supposed to sit this way, but in any event, in both directions there's about 200 ohms on that wire. And if you read anything, it should read like a diode drop in one direction. Yeah, it appears to be like a 200 ohm load on there. I'll try a different meter. So we'll go to ground. 250 ohms load on that. And in the other direction, 250 ohms. So there's 250 ohm load on this lead somewhere. So I'll have to trace where this wire goes. Goes to the other side of the unit. So at 35 volts, 250 ohms could be quite a bit of power. So if we go 35 35 squared divided by 250 ohms, that's 4.9 watts. Going someplace. So we have to trace that out. So I checked the negative lead, which is symmetrical really with this type of power supply. It's a plus and minus 35 volt. The negative lead doesn't have any 250 ohm load on it anywhere, so we'll have to trace this out. So I traced that wire down to this lower board here, this red wire here, and that shows the 250 ohms in either direction. This is the minus side. It shows 690, which looks like a diode drop, which it should. And there should be nothing the other way. And there isn't. So we do have 200 ohms somewhere on this board being developed. So with all this, got to go through and find a short. Well, it's looking more and more like there's other issues here. I just flipped it over and the power supply on the other channel here is all burnt. This is the Phono preamp section, and the 9 volt, the plus 9 volt here, the regulator diodes are shorted, or actually this one's open. I haven't even checked the transistor. It's looking like whoever had it apart before hooked the power supply up wrong and put 35 volts on the 9 volt. Because this is the 9 volt, and the 9 volt is actually the red here. So I'll bet they thought the red was the higher voltage of 35 or something. So this is really going to be quite a situation. I found these two pass transistors. One is leaky, the other one's open. They're in parallel. 224 was okay, 224. And ZD201, Zener 201, which is a 7.5 volt Zener, was also bad. But this FET here is okay, which surprises me that the Zener's bad, but the FET survived. So I got to find replacements for these two transistors here, and hopefully it'll get rid of that 150 ohms I was seeing over here, or what was it, 250 ohms. So we'll find some substitute for that, and the Zener 7.5 volts. So I found a replacement for these two transistors here that should work, which go right here. The original transistor is a 2SC 2240, and I found a MPSA 18 that should work. The voltage is different. I don't know why they use such a high voltage transistor in the original here. 120 volt when we're only using 9 volts, but that's probably all they had, or they were trying to use the same transistor for different areas. But in any event, they both are good for 100 milliamps. The MPS 18 has a little bit more power dissipation, 625 milliwatts, where the original 2SC 2240 here is 300 milliwatts. And there's a couple other characteristics I was looking at here, just to make sure that it matched pretty well. Mainly the noise spec. The noise figure here on the original 2SC 2240 is 6 dB, and that's at this VCE is 6 volt, 0.1 milliamp, 10 hertz, 10 kilohertz or 10 kiloohms load. And this one here is 1.5 dB noise level. So this should work as a replacement. Because all this is a regulator circuit, but it is part of the Phono preamp, and there's no decoupling of any capacitance here. So these noise figures of all these transistors have to be really low. So we're gonna put the MPS A18 in there for that and see how that works out. This Zener here was also blown. It is a 7.5 volt Zener. So to replace that, which is right here, ZD201, a 1N5236 will work for that. Probably can't see that, but in any event, this is a 7.5 volt Zener, so put that in there, and then we're going to try to find a way to test that part of the circuit without powering up the whole thing. All the parts are replaced now in this section that was burned out. Now I'm going to force feed 9 volts into the circuit here, plus and minus 9 volts around ground. This is the virtual ground we have here. And see if there's 6 volts, supposed to be 6 volts plus and minus feeding this circuit here. So I have it wired in here, so I removed the wires going off to the other power supply and other boards, so it's totally isolated. So I'm going to force feed 9 volts into here. This J11 is common ground, or the virtual ground. And we'll look at the 2 emitters here. The emitter of the plus supply and the emitter of the minus supply, and it should be 6 volts or thereabouts. And if it is, then we can maybe put a signal into here and see what happens. Okay, we got 6.6 on the, this is the side I had to repair. So we have 6.6 volts on the positive side. And then the negative side, which is these 2 transistors, is 6.6. So it's balanced. It's a little high, but I think the Zeners show the correct voltage. Actually, that Zener, that's the original Zener on the negative supply, is a little bit low. And the new one I put in is just about right at 7.5 volts. So the 6.6 is probably okay. But this whole circuit is the moving coil amplifier stage, and it's got to be really, really quiet. So I'm going to put a small signal into the input of this now and see if we get a signal through it. And if we do, I don't think there's any more needs to be done to it. Hopefully not. Got the scope probe connected here to the switch, and we've got an input on the back with a 1 kilohertz coming in to the moving coil amplifier. And we're looking here at the switch, and it appears the amplifier is working fine. I'll show the scope here. So I got the oscillator here, putting a signal in about minus 45, and we've got a signal coming out of the moving coil cartridge preamp section of this Nakamichi. We go to the other channel and fix it looks like the same issue. So now we continue. Now to work on the left channel. The board is a mirror of the right, so everything's on this side now. And this whole area is burnt, which is the same area as the right channel. So I would imagine a lot of the parts here would be needing replaced, just like the right channel. So this one's going to be a little more work to get out because there's a lot more wires involved here. Okay, I'm going to pop these parts out of here These are definitely bad, the two transistors. And probably the Zener also. So I'm going to pop these out. And we'll do the same as we did with the other channel. Okay, got the bad parts out. Where the Zener was really burnt the board really bad here. So I might have to do some carbon scraping, get some of that carbon off. And the two transistors, just like in the other channel, are replaced now, or will be replaced with MPS-A 18 right here, two of those. So I'm going to try to clean this up a little bit here. Yeah, that Zener burnt quite a hole here, but since it's low voltage, this shouldn't be too much of a problem. If this was high voltage, it'd probably arc here. So we'll go ahead and put in the new parts. Okay, I'm going to force feed 9 volts in. Like the other channel, look for plus and minus 6, and we got 6.2, which is good. And we'll just look at the negative side real quick. Okay, we're good. So like before, I'm going to run a signal into the MC, the moving coil cartridge input, and check this amplifier and make sure that these regulators are now functioning properly. So we're going to force feed the 9 volts in and see what happens here. And we have a nice sine wave coming out. So the moving coil preamp on this channel now is functioning. So we're making some headway. Okay, got to get the power supply ready to mount. Gonna clean up these holes where the power transformers connect to the board. And we're going to power this supply without connecting it up to anything else, just to check all the DC voltages and see if they're okay before connecting it back up to the amplifier section. Got a lot of testing to do yet. Got to get this power supply board wired back in. Luckily the wire color codes are here, marked on the board. You can see pink, and the violet. So that at least makes it easier to hook this thing back up and get everything soldered back together. And then we can test this board here. So I'll get all these wires put in and we'll power up just the power supply and see how it goes. Okay, I'm going to measure these voltages. Got the power supply installed. So the 9 volt is here. Nope. This is where the screw up was. Whoever got into here. They got R. The red lead, they wrote it in here. Well, the red lead, it's plus 9, not plus 36. You can see where somebody had written in that the red lead goes here. And that is the plus 36, not the plus 9. The plus 9 is over here, where they had the yellow leads. So they had these fully reversed. And that's what blew up everything. So anyway, I'm going to measure these real quick. This is 34, which is close to the 35. Minus 34, so we're good there. Plus 9 and minus 9. So everything appears to be working now on the power supply. So that's what blew up these parts on the power supply, is they connected things up, the 9 volt to the 35 volt, which toasted both channels on those regulator inputs to the moving coil preamp. Let's hope no other damage was done, because if they hooked the 9 to the 35, they probably hooked the 35 to the 9, which wouldn't have hurt it anything there. But hooking the 9 volt preamps to the 35 volt, that definitely hurt some stuff. So hopefully there's nothing else wrong, but we'll get this thing set up and I'm going to get these markings off of here, tried to, with some alcohol that somebody put there, but they really screwed it up doing that. So let's move on. Okay, I relabeled these: red, blue, which is the 9 volt, yellow, white, which is the 35 volt. And I was able to take some isopropyl and get rid of those ones that were written in wrong. So now we can connect it up and see what happens. Time to power it up and see if we get any smoke. Everything is wired here correctly. Got the red, blue, yellow, white, which wasn't correct when I got this thing. So anyway, here we go. Yeah, I heard a couple of relays pull. The logic seems to be working. You can hear the relays click. Okay, so we're going to be putting some signals through this thing next. This is kind of a mystery mod. When I first took the unit apart, took the cover off, this resistor was in there to chassis ground. And by looking at the schematic, it's right here, tying this point where it looks like the regulation point actually to ground. Now I fired up the amp without this and none of the relays would pull, and then I measured the plus and minus 35 and it was down to like 2 volts. So for the heck of it, I put the resistor back in and everything's working fine. So this is a mystery. This is a mystery here. Was this supposed to be on the board in production? And it wasn't, and it was a later mod put on. I don't know. So I'm going to clean this up a little bit, try to turn it on again, and we'll see if all the relays pulled in, and then I can get some sound through this. But yeah, that's a mystery resistor right there. So to clean this area up a little bit, like that, I've got this Allen Bradley metal film. This is a 3 meg metal film. I don't think that 3.9 meg is that critical, but I don't know where that mod came from. I don't see any reference to it, but without it, the unit relays won't pull when you hit the front buttons in the power supply. So I'm going to put this resistor in and tie it to this ground screw via a lug and a lock washer that'll grind into the bolt a little bit. Because this bolt is plated, I already took a little sandpaper to make sure it makes contact on the chassis underneath. So we're going to make that mod and give it a try. I made the mod in here with the 3.01 meg resistor, a lug, and then went to the ground screw here with a lock washer underneath here. So that should do the same as the little kludge that was coming all the way out here to this screw. So everything should work now. Okay, I'm going to power it up. And relays are clicking. Right now I'm in the moving coil phono input with a very low level signal. And we have an output. So I'm going to get a scope out here and check the whole thing out through all of the inputs. Okay, I'm using the moving coil phono input right now, and the waveforms look good, and it does clip symmetrically. So it looks like both channels are doing well. This balance act's kind of strange though. It it just shuts the channel off all the way over, and then it doesn't really the balance, it balances to a point and then just shuts the channel off. So that's kind of an odd feature. But right now this is the moving coil input I'm testing at the moment. And now I'm going to switch over to the moving magnet input. Okay, this is the moving magnet phono input. It seems to be working quite well too. Of course it should, because the moving coil preamp drives directly into the moving magnet preamp. We'll try the line levels now. I'm going to have to give it a lot of input signal now. Okay, tuner input is working. CD. CD input is working. This is aux1. aux1 input is working. This is aux2. aux2 input is working. Okay, got to figure out tape 1 play. Okay, tape 1 play is working. This is tape 2 play. So tape 2 play is working. I'm going to go back to, say, an aux1 input and see if the tape outs are working. Okay, so we got aux1 going in, and we're going to come out the tape record 1. Oh, there's quite a bit of gain on that tape out. So that's tape out number 1, and that's all selected with this record out selector. So with record out on tape 1, the selector's on aux1, which is the input I'm using, and the volume control has no effect on the tape outputs, which is the way it should be. So now I'm going to try the tape 2 record, and it's working also. So the tape 2 record is working also. So it looks like everything's working fine here. And there's 2 outputs, and I'll double check those. Now this is through the volume control, and out 1 is working. And out 2 is working. So we should be ready to put this back together. It seems to be repaired. And then we'll go over what was wrong with it in the beginning there. Got all the wires retied here into a nice bundle. I notice there's screws missing here on the side panel. So I'm gonna look through this box of metric screws and see if I can't find something for these 2 corner screws. Then we'll be ready to slap the whole thing back together after cleaning the knobs and so on in the front. Okay, I pulled the knobs off. I'm going to clean this recess area here, so it always gets full of dust and dirt. And we'll clean that, and then clean the knobs themselves. Need to get the dust off of the switches and stuff in the back here too. Make the nice gold show up. Not too shabby. Okay, it's pretty much done. And just a final check. Got a signal going through it. And it seems to be working pretty well. So the owner just needs to find a switch there, or have one made for the missing CD switch. But everything else is working fine.